Today I wanted to talk about T COIL exchangers. They are very particular exchangers. I will demonstrate one to you right away in order to make it clear. Here it is. This is an example of a classic T COIL exchanger. Here are the methods of attack for fluid entry and exit. These fittings are specifically designed for male gas-threaded connections. This is also a heat exchanger made for a food application. So you have observed that it is also electro-polished, so it appears very nice. It looks really good. Clearly, not everyone possesses this level of finishing. What exactly are T COIL loop systems? T COIL heat exchangers are specialized heat exchangers typically employed for immersion. They are exchangers that do not have a specific standard, but are manufactured according to customer requirements and can therefore be produced in the sizes and shapes that are most beneficial for the intended use. Where they are applied in many fields, when we really use them from the food sector to the chemical, to the pharmaceutical, to the paper industry, and the uses that initially were mainly born for immersion uses in tanks rather than in channels to thermostat and regulate the water. In fact, they have also expanded into other areas such as cooling grains and cooling powders that are applied as clamps on the outside of tanks for tank thermostating, instead of creating an external tank like they used to do before. To show you, I'll let you see a few interesting videos. How are T COIL heat exchangers made? The realization is simple but at the same time complex. Let us assume that there are two sheets that are welded around the perimeter, typically using stainless steel AIC 304, 316, and other materials may also be utilized. Well, I was stating that there are two sheets that are welded all around the perimeter, then spot welded in a pattern that is determined by the type of fluid that flows inside, and then inflated under pressure from the inside in order to create the bulge that we have observed. This bulge creates a chamber inside which the heating or cooling fluid can flow. The plate immersed in the fluid obviously transmits heat or absorbs heat, acquires energy, and therefore creates thermostasis and heat exchange. I was asking why the material of the plates is noisy, simply because the material that is cold can be deformed without breaking. The carbon steel would not have the ability to deform in this way after welding, without cracking, therefore without breaking, therefore resisting pressure. They can be used with steam, thermal oil, water, superheated water. The applications are truly numerous. The size limit is simply related to the dimensions of the sheet metal available on the market. Just because being welded sheets, we have to start from semi-finished products that we find on the market. So either pre-cut sheets or coils, so different lengths and sizes can be made. Then the shape is actually very customizable and the applications are really numerous. I would say that we have found many, and every year some new ones come out that we didn't even think of. And I must say that they are really very, very interesting. What do you think?